Hello, so this is a quick video on two parent functions, absolute value and radical. And the reason we care about parent functions is it provides us sort of a good starting point when looking at different relationships and what they might look like graphically. So for example, probably one of the most common parent functions is f of x equals x, or y equals x. And to graph that, it's just, it's linear, we know that. It's got a slope of 1, and it just kind of bisects these quadrants here. And once we do things to this, so if we were to change this function, if we were to say f of x equals x plus 1, this whole thing is now shifted up 1 because it's going to have a y-intercept of 1. And so it's going to be parallel, same slope, but it's been shifted up. And so that's an idea of a really simple, I guess, example of a parent function, linear, and then we know what this plus 1 does to it. We also know what happens if we change the slope, right? It gets steeper or less steep, flatter, if you will. And so we're going to look at just the parent functions in this case of absolute value and radical. And then in class, we're going to use Desmos and some kind of a different exploratory things online to help us see what different variables do to these sort of functions. We're also going to look at a variety of functions other than absolute value and radical, but those are the two I wanted to cover in this video. All right, let's get started. Okay, so taking a look at this particular sort of relationship, we're saying that f of x is defined as the absolute value of x. So again, a simple equation, but how would we go about graphing this? Well, in class, what we're going to do is we're going to work to graph every parent function, and then we're going to have a table of a few values to kind of help us along. So the first thing I'm going to do is I'm actually going to create a table. So this is my functional output on the right, and then on the left, I'll just put in some inputs. So what happens when I plug in 0, for example? Well, when we plug in 0, we obviously get an output of 0. So, because the absolute value of 0 is 0, right? When I plug in 1, I get 1. When I plug in 2, I get 2. It doesn't really matter. If I plug in a positive number, it's going to come out and be itself because I'm saying f of x equals basically the absolute value of x. So it's going to mirror itself. But if I started putting the negative version of these numbers, I get the positive versions as the output. And so this creates kind of an interesting looking graph. And it looks something like, whoops, let's see if I can get that somewhat straight, at least attempt some neatness. I still haven't quite figured out how to make these, how to get, I guess, my software in such a way that's easier to do straight lines, but I'll figure it out eventually. So as you can see, if we were to graph 0, 0, we'd have a point here. At 1, 1, we'd have a point here. But we also have this point at negative 1, 1. So it's going to kind of mirror itself on the left-hand side. And this is similar to, you might kind of see a few similarities between this function and what we've called before a simple quadratic function, in the sense that it does kind of mirror itself left and right. But the difference is it's kind of two rays rather than a curve, right? It's not a parabola. And so, for example, if we continue this out, we get 2 and 2. We get negative 2 and 2. And so we actually end up getting this V. Basically two rays. We get this angle. And in class, I'm going to ask you what the angle is. What do you suppose this angle is? And so that's all there is to an absolute value function to graph it. And I guess putting those inputs and calculating those outputs kind of let us extrapolate that these lines are going to continue on forever, just like this. Because I could plug in, for example, 55, and I'm going to get positive 55. Whoops, let me write that a little bit better. Positive 55, and I can plug in negative 55 and get positive 55. So even with, I guess the idea here is that even with x's that are integer opposites, we end up getting the same y. So this would be, way off to the right, way down there at 55, we're going to be way up there at 55. Way down here at negative 55, we're going to be way up there at positive 55. So this thing's going to continue to sort of mirror itself. It's not really mirroring necessarily, but I probably shouldn't use that word, but it's kind of replicating itself on the right-hand side and the left-hand side of the y-axis. All right, let's take a look at the radical function. That's the last one for this video. So in this case, if we have f of x equals the square root of x, this is radical, not because it's cool, but because we call the symbol above the x a radical sign. And so similarly, we'll do our table of values. If I plug in 0, square root of 0 is 0. Plug in 1, I get 1. And for the sake of graphability, I'm going to plug in perfect squares. So if I plugged in 4, I'd get 2. If I plugged in 9, I'd get 3. 16, I'd get 4, and so on. But what you might notice, what's special about this graph, is it's, difficult for us working with real numbers to plug in negatives. So like negative 4. As of right now in our Algebra 1 understanding, we aren't really evaluating these yet, right? And in Algebra 2, or whenever you feel like learning it, you don't have to wait, we'll learn about imaginary numbers and how they pertain to situations like this. But for now, let's kind of stick with real numbers to get these functions understood. And then if you want to, if you understand this, feel free to research how do you take the square root of a negative number and what does that mean for imaginary numbers and how does that connect to the coordinate plane? Those are all great questions to have. So if we were to graph this, it's going to end up looking something like, and I'm actually just going to roughly sketch this. I'm going to have my point at 0, 0, then I'm going to have, of course, 1, 1. But then as I go out to 4, 2, 3, 4, I only go up to 2 here. And so it actually becomes a curve, and it kind of continues on in that shape, almost like it's basically half of a sideways parabola. It's really exactly what it is. But there's nothing under here. So what I'm drawing underneath right now really doesn't exist right now with this function. It would mirror itself if I went ahead and graphed f of x equals the negative square root of x. It would end up mirroring itself on the other side. But as of right now, with just what I've done here with this function right here, square root of x, we're only going to get what appears to be red here because there's no way to get a negative value. The square root of any positive integer is going to remain positive. All right, guys. Thanks for watching, and good luck with your homework assignment. Let's get those parent functions graphed.